All right, this is momentum and energy. Part 2. So we left off with number 4. A golf club strikes a ball. The club and ball remain in contact for that seconds, and the 0.50 kilogram ball leaves the club with a speed of 80 meters per second. Calculate the force of the club on the ball. So you're going to use this equation. They gave you a mass, they gave you a time, and they gave you a velocity, and it says find the force. So if you go up to the previous page, the equation that we're going to use is force times time equals mass times the change in velocity. And we're going to plug in to that. We're actually going to go ahead and just divide both sides by t real quick because that's going to be easier. And that's going to give you F equals mass times the change in velocity divided by time, and that's going to give you 0.050 times 80 divided by 0.00070, which means that the force equals 5,714 newtons. A force of 8 newtons causes an impulse of 24 newtons per second, or newton seconds. How long was the force applied? So you're going to use this formula, J equals Ft, and you're going to go ahead and plug in. You know that your force is, or your impulse is 24, your force is 8, and solve for t, so t equals 3 seconds. A braking force of 5,000 newtons, that's force, is applied for 8 seconds, that's time, on an 1,100 kilogram truck, that's mass, causing it to stop. So velocity equals 0. How fast was the car traveling? So we want to know the initial speed. So we're basically looking for VI. So that's going to basically be VI minus V2 is the change in velocity. So that's what we're trying to figure out, is how fast was the car going if it stopped now. So again, we're using Ft equals m delta V, and I know my force is 5,000. My time is 8. That shouldn't be a negative sign, that should just be 8. Equals my mass, 1,100. Times my delta V. And if you solve for delta V, that's going to give you a delta V, a change in velocity of 36 meters per second. So moving on to number 7, a basketball has a momentum, that's P, of 25 kilogram meters per second and a velocity of 5 meters per second. What is its mass? So we're going to use this formula, P equals m times V, and I'm going to have 25 equals mass times 5, and that means that my mass is going to have to be 5 kilograms. What is the velocity of a 0.02 kilogram bullet mass would have to be traveling to have the same momentum of a 7,000 kilogram truck, that's another mass, traveling at 50 meters per second? So this is a slightly different question. This is basically asking us, if I have the momentum of this truck, momentum of that truck, how fast would this bullet have to be traveling? You can do this a couple different ways. I think the easiest way to do this is m1 v1 equals m2 v2. So I'm going to go ahead and plug those numbers in. 0.002 times the velocity 1, I don't know that, that's what I'm trying to solve, times the mass and the velocity of the truck. So equals the mass of the truck times the velocity of the truck. And so that's going to go ahead and give me a fairly large number. It's like 350,000, sorry, 350,000, and I'm going to divide that by this. So when you do that, let me go ahead and do that. 350,000 divided by 0. The band is driving me crazy. 0.002. 0.002, and that's going to equal my velocity. So velocity here equals 1.75 times 10 to the meters per second. Let's move on to number 9. Number 9 says, what braking force would a car need to stop a 1,500 kilogram truck moving at 30 meters per second in 4 seconds? So I'm looking for force. I have a mass, I have a velocity, and I have a time. So I'm going to use this formula, Ft equals mass times delta V, and I'm going to go ahead and solve for F. So I have F times 4 equals 1,500. Or does that say 1,800? Nope, that says 1,500. 1,500 times 30. And then I'm going to go ahead and solve for that. I'll divide both sides by 4. And that gives me a force of 11,250 newtons. Okay? An 1,800 kilogram SUV is moving at 20 meters per second. If the brakes supply a force of 3,000 newtons, how long time does it take for the car to stop? So I'm using the same formula again, Ft equals m delta V, and I'm going to plug in what I know. 3,000 T equals mass, 1,800, times my change in velocity, because I'm going to go from 20 meters per second, 20 meters per second to 0 meters per second. That means that I slowed down 20 meters per second. So when you solve for that, T is going to give you 12 seconds. Number 11. If object 1 and object 2 have the same mass, so m1 equals m2, but object 1 is thrown with a greater velocity, which one has a greater momentum? And the answer is 1, because this is bigger. Which has more momentum, a large truck traveling at 30 miles per hour or a small truck? And the answer is a large truck. Duh. Number 13. Explain why it is good to bend your knees when you land from a jump. Use impulse change and momentum theorem. So basically when you bend your knees, it lengthens the time. So you're going to get a decreasing impulse because you're multiplying by a shorter time period. So complete the following statements. In any collision, the initial momentum is blank to the final momentum. It should always be equal. If it is a perfect system, it should be an equal momentum. If two objects have the same velocity, the object with blank mass will have more momentum. The object with more mass will have more momentum. If two objects have the same mass, the object with blank velocity will have more momentum. That's question 13 or question 12. So that's more. In an elastic collision, kinetic energy blank. So in an elastic collision, that is when all of the kinetic energy is conserved and it just bounces back and forth. So that's going to be constant. In an inelastic collision, the kinetic energy decreases because that's like when something rumples and the kinetic energy is going to be transferred to heat. So let's look at the conservation of momentum problems. An explosion propels two objects in opposite directions. Object 1 has a mass of 5 and moves to the right at a speed of 40 meters per second. Object 2 mass is 7. What is its velocity? I don't know. So let's go ahead and plug that in. That's 5 times 40. We're using this formula. m1 v1 equals m2 v2. It's right here. So 5 times 40 equals 7 times v. And that is going to be 200 equals 7v. So v equals, it's actually going to be negative. Sorry, I forgot my negative sign there. It's going to be negative 28.6 meters per second. Why is it negative? And here's the deal. Like if I'm here and there's another object here and so if they hit and they bounce in opposite directions, so like let's say that this one bounces back and that one bounces that way, then they're going to have negative because it's an elastic collision. They have opposite velocities. An astronaut in space throws an 8-kilogram bowling ball at a velocity of 4 meters per second. If the astronaut is 90 kilograms, how fast does he fly away from the bowling ball? So we're looking for V2. So you're going to have 8 times 4 equals 90 times V, negative 90 times V. Because again, it's negative. See that right there? So we're going to go ahead and we're going to have this be 32 equals negative 90V, and V is going to equal negative 0.356 meters per second. To sig figs, that'd be negative 0.4. Now, in an elastic collision is a collision where all of the kinetic energy is going to be conserved. We're going to use this equation that we use today in class. Because we use that equation today in class, I'm not going to spend a lot of time on this first problem. So M1 equals 0.2, V1 equals 1.5, and it says it's going to hit a stationary pool ball that has the same mass. Stationary pool ball with the same mass. So that means M2 equals 0.2 and V2 is 0. Okay, so I've plugged in this part here. Okay, so I have 0.2 times 1.5 plus 0.2 times 0 equals, now I've got M1, already got that, V1 prime. V1 prime just means how fast is it going after. That's this. V1 prime is how fast I'm going after the collision. So this ball, M1, 0.2, is going to be going 0.5 meters per second after the collision, plus the mass of the second object, 0.2, because the mass did not change, times V2 prime, V2 prime. Okay, and when you solve for that, you get 1 meter per second, as we did earlier today in class. So let's do this next one. A bumper car has a mass of 500, rams another bumper car at rest. So the first bumper car is moving, the second bumper car is at rest, 0, with a velocity of 10 meters per second. So this one is going 10 meters per second. The second bumper car has a mass of 400. If the first car continues to go at 2 meters per second, that's V1 prime, 2 meters per second after the collision, what is the velocity of the second one? So that's what I'm solving for. So let's plug in 500 times 10 plus 400 times 0 equals 500 times 2 plus 400 times V. And that's what I'm solving for, is this new V. So this is 5,000 plus 0 equals 1,000 plus 400 V. 400 V. So this is going to be 5,000 minus 1,000. This is going to be 4,000 equals 400 V, and so V is going to equal 10 meters per second. And I will continue this in the last video.